Oh, please be careful when you're handling that.
Mathilda, you told me this was light and fragile, but they feel really, really sturdy. You know, I've got them in my hand. Oh. Sorry, Mathilda. Previously, we've looked at Kanthal metallic elements. Today, we're looking at something quite different. Mathilda, this doesn't look metallic to me.
No, it's not. It's ceramic. It is based on molybdenum disilicide.
Good word.
Yeah.
I'll let you keep saying that.
Yeah. So what this really means is that we can reach a much higher temperature.
What temperature are we talking about?
All the way up to 1850 degrees Celsius.
So that is a lot hotter than metallic elements that we've seen in the past.
It is.
Tell me a bit more about the elements itself. How often should we look to replace the elements?
Replacement really depends on your application.
Yeah.
We have seen some cases where they can go on for months, even up to several decades. But if you have a really aggressive atmosphere, then you will have to replace it maybe every temperature cycle.
You've got an example here of a used element.
Yes, I do. So here you can see that the oxide layer has started to react with the atmosphere.
I can indeed, yeah. It looks completely different from the new elements.
Exactly. And if you look very closely here, you can see that we have a smaller diameter.
I can, yeah.
So what this does is, if you have a diameter reduction, it will change the resistivity of the element.
And what happens to the elements when that changes?
You will get a higher element temperature for the same amount of power supplied.
And that is going to cause issues with the process.
Yes, and it will also result in overheating, which will break the element.
Also, we're going to look at how to replace an element. Are you going to replace the elements?
No, I will not do that. We will bring in our electrician, Thomas.
Thomas, you're going to show us how to assemble the elements.
Yes, I will.
Now, is this one person can do this?
One person can do it, but it's better be two to be sure you don't break it.
So what we're doing now is obviously we've taken the elements and we're actually putting it through the insulation block. We've got the termination end here.
Yeah.
How long should the termination end come from in the insulation block?
The minimum is 150 millimeters.
And that's to ensure that the terminations don't get too close to the insulation and don't overheat. So even though the actual hot zone side of the elements is going to be in here, we're still going to get some heat radiating up the termination. So obviously what Thomas is doing is he's going to put some actual fibre in the top end, and this is to stop the heat radiating out and overheating the terminations. And next, what do we have here? The retaining clip. So we've got that in place now, so that's pretty much assembled. And then the last bit is to assemble the terminations.
Yes.
So the retaining plastic part, just keep that in until you can slide that out. And obviously that makes it a lot easier for the termination to stick on the termination end. Thomas, have you completed the terminations there?
Yes, now we have.
We're going to take this to the furnace now and we're going to change the elements. Come and join us. We're here at the ingot rolling mill at Kanthal. Mathilda, it's really noisy in here.
It is.
It's nearly as noisy when my children come home from school. Relatable?
Very.
What we're going to do now is we're going to show you how to replace the Kanthal Super Elements that we assembled before into this pit furnace. Are we ready to replace the elements?
Yes, we are.
Okay, let's go. So how long does it usually take to replace a Kanthal Super Element?
Well, it depends on the application. If you have a small lab furnace, it could take about 10 minutes, but for larger furnaces, it's about 30 minutes.
And we've got a large furnace here.
We do.
And obviously we've got Thomas and Marcus replacing the elements here. Just take me through the steps of how they're going to replace this large element.
Well, first they have to disconnect the electricity, remove the plugs, and then they will also remove the bolts from the terminals.
Yep.
And then they just pull the element out.
As simple as that.
Simple as that.
And obviously there they go, that's coming out, quicker than I thought. And this furnace is actually hot.
It is.
And they're going to put the new elements in hot.
Exactly.
And what are they going to do when they put the element back in?
Well, it's really the same process as they did when they took it out, but in reverse.
Okay. What mistakes should we avoid when replacing a Kanthal Super Element?
Well, the first thing is to make sure that you're really careful. As you know, they are very brittle in room temperature.
Yeah.
Yeah. And then you also have to make sure that you don't plug in the electricity too quick, because the element has to reheat itself again. If you join me back at Super Lab, I can explain more.
Okay, let's go. We're back in the Kanthal Super Lab. We've got a Kanthal Super Elements. Mathilda, tell me about some of the features of the elements.
So, one of the things that is really unique about the Kanthal Super Element is that the resistivity is both temperature and material dependent. So, for example, we have a range of, when it's at room temperature, the elements are at about 0.4 ohms millimeter squared per meter.
Okay.
And then when you heat them all the way up, they can reach 3.8 ohm millimeter squared per meter.
So that changes as you start to actually increase the temperature.
Yes, exactly.
And that is critical, obviously, when you start to heat the elements.
Exactly. And we also have different curves, resistivity curves for the different materials that we can have in our elements.
And we can show that to the customers. What else can the element do in terms of working in different atmospheres?
It can handle both endogas atmospheres, hydrogen, vacuum, reducing atmospheres. All of that works well with the Kanthal Super Element.
So that's great for any application that you may be doing in different atmospheres.
Yes, exactly.
Okay, that's great. Mathilda, thank you. Let's wrap that up. What have we learned today? Kanthal Super is a high-powered molybdenum disilicide electrical heating element utilised in high temperatures, demanding applications and atmospheres. You can change an element in a furnace when it's hot or cold. Be sure not to turn on the power too quickly. Handle the element with care, and thank you for watching. Now, nobody told me these were ceramic elements. All that I've ever dealt with is metallic ones. You know, we do these videos and no one helps you, no one gets any help. Well, there's no one here now and I've got to brush these all up myself. So never mind, come on, let's get it done and go home.